Hey everyone! Welcome back to my channel where we solve LeetCode problems together. Today we're going to tackle a problem that's all about checking if an array is sorted and rotated. This is a great problem for beginners and experienced coders alike. So let's dive in and see what we can learn. So the problem asks us to determine if a given array is sorted and rotated. What does that mean? Well, imagine you have a sorted array. And then you take a portion of it and move it to the beginning. That's a rotation. For example, if we have the array 1, 2, 3, 4, 5, a rotation might look like 3, 4, 5, 1, 2. The key here is that the array is still mostly sorted, but it's been rotated. The core insight behind this problem is to understand that a rotated sorted array will have at most one point where the values decrease. Think of it like a mountain range. If you're walking along a mountain range and you see a peak, that's like the rotation point. After that, the values should always be increasing. Unless, of course, the original array was already sorted, in which case there's no rotation point at all. It's like a flat plane, where all the values are in order. So how do we use this intuition to solve the problem? Well, we need to iterate over the array and count the number of times the value at an index is greater than the value at the next index. This will tell us if we've found a rotation point. And then, after the loop, we need to check if the last value is greater than the first value, which would indicate a rotation. If we've found more than one rotation point, then the array isn't sorted and rotated. Let's take a look at the code and see how this works. We start with a class called solution and a method called check that takes a vector of integers as input. We initialize a variable called count to 0, which will keep track of the number of rotation points we find. Then we iterate over the array, and for each index, we check if the value at that index is greater than the value at the next index. If it is, we increment the count. After the loop, we check if the last value is greater than the first value. And if it is, we increment the count again. Finally, we return whether the count is less than or equal to 1. This is the key line of code, because if the count is greater than 1, then the array isn't sorted and rotated. Let's go through it line by line. We have int count equals 0, which initializes our counter. Then we have a for loop that iterates over the array. And inside the loop, we have an if statement that checks if the value at the current index is greater than the value at the next index. If it is, we increment the count. After the loop, we have another if statement that checks if the last value is greater than the first value. And if it is, we increment the count again. Finally, we have the return statement, which returns whether the count is less than or equal to 1. Now, let's talk about the complexity of this solution. The time complexity is O(n), where n is the length of the array, because we're iterating over the array once. The space complexity is O(1), because we're only using a constant amount of space to store the count variable. And that's it for today's problem. I hope you guys learned something new and had fun solving it with me. If you have any questions or you'd like to share your own approach, please leave a comment below. Don't forget to like the video, subscribe, and comment your approach below.